Today's lesson, we're looking at scatter plots. We've looked at graphing linear relationships, and when we're graphing linear relationships, we'll notice that when we're plotting our independent and our dependent variable, the points all lie exactly on the line. That's a linear relationship. But with a scatter plot, they may line up, right? Or they may deviate from the main line. Maybe sometimes they will deviate completely away from the line. And that's what the scatter plot, right? They're scattered all over the grid, right? And that's where we get the name scatter plot. Now, you can use a scatter plot to display data involving two variables, right? Our two variables are independent and our dependent variable. And what we want to see is there a relationship between the two variables? When we were talking about money earned with the hours worked, there was a relationship between the two, right? They related. I made more money if I worked more, right? But if the two variables maybe have nothing to do with one another, right? If you look at one of the examples in your book, it asks you to plot wrist size as one variable and neck size as the other variable. So maybe there's a relationship there, maybe there's no relationship whatsoever. Okay, and that's what we're going to try to identify with today's lesson. So, when we're plotting points for a scatter plot, we are always looking for a correlation, some kind of relationship that occurs between the two variables, right? So, correlation helps to describe the relationship between two quantities in a graph. A correlation can be described as positive or negative, right? So we may have a positive correlation, a negative correlation. We may have something called a strong correlation or maybe a weak correlation. Maybe we might find that there is no correlation whatsoever between the 2 points. Maybe the two variables that we are plotting have nothing to do with one another. Right? So maybe we could plot something like marks, right? Your percentage up to 100% based on who's wearing red. Right? So if you're wearing red, you know, and what mark. So is there a correlation between the color red, wearing the color red, and the marks that we achieve? Right? We can always do a plot like that. Right? And see, is there a correlation? That's what I'm talking about in terms of taking two variables and trying to plot them on a scatter plot. So, let's look at what a positive negative correlation goes. So, a scatter plot shows a positive correlation when the pattern rises up to the right, which is uphill from left to right. So, here we have our line of best fit from our points, and they go as such. So, when the line of best fit, right, we don't connect the points, never connect the points. Right? It's not a connect the dots. Right? We're drawing a line of best fit. So in that line of best fit, when it goes upwards from left to right, this is considered a positive correlation. So this means that the two quantities increase together, which means here is my independent variable, here's my dependent variable. As this variable increases, right, because the numbers are starting from 0 and they're going in this direction, they're increasing, so is the y-axis. That's also increasing. Okay? So notice here we have this increase between the x and y at the same time. As one's increasing, so is the other. Right? Now, let's look at the next one. A scatter plot shows a negative correlation when the pattern falls down to the right. So downhill from left to right. So we're going downhill from left to right. This is considered a negative correlation. Okay? So we're going downhill. Now, what does this mean? This means that as one quantity increases, the other decreases. So here's my x, here's my y. Which one is increasing? Which one is increasing? Which one? The x, exactly. My x-axis is increasing. So x is increasing as my y here is decreasing. So my higher values are higher up in the grid, right? And we're reaching down to 0. Strong or weak correlation. So let's look at the first grid there. If the points nearly form a line, then it is a strong correlation. So if you look at the points, pretty much look like they form a line. To visualize this, enclose the plotted points in an oval. If the oval is narrow, then the correlation is strong. So what do I mean by an oval? So I'm going to try to circle around the points, as close to the points as possible. And now notice I'm not forming a circle, I'm forming pretty much a very narrow oval. Right? So because the oval is narrow, the correlation is considered strong. So we look at the next one, and we do the same thing. You're not going to really do this, you're going to try to visualize this. Right? So if we look at that now, this oval is slightly wider, but they still kind of form in a straight line. So if the points are dispersed more widely, but they still form a rough line, then it's considered moderate to strong. So this one's a little more strong, right, than moderate. Because if we look at the points, yeah, maybe they don't lie exactly on the line of best fit, and we're just trying to visualize it there. Right? But for the most part, they do. So we can consider that as a strong correlation. If we look at the last one here, and we do the same thing, notice now as I'm wrapping around, the oval gets a little bit wider. Okay. So when the oval gets a little bit wider, this is what we look at in terms of being a weak correlation. So if the points are dispersed even more widely, but still form a rough pattern of a line, okay, so here's our line of best fit, right? This is the thing that's most important, that line of best fit, and how far away are the points from that line of best fit, right? And then visualize the oval, right? So we have here pretty much a weak correlation. Maybe we could consider this slightly stronger than weak. We might look at it as a moderate correlation, but for the most part it's weaker than the first two examples, right? Now, in terms of positive, negative, this last example, is it a positive or negative correlation? Negative. The first two are positive. Good. So the first two examples, these are both positive correlations, right? And yet they're still considered strong correlations. So they're considered strong positive correlations. This last one is a negative correlation, but it's a weak negative correlation. And lastly, no correlation whatsoever. A scatter plot shows no correlation when no pattern appears. If the points are roughly enclosed by a circle, there is no correlation. So remember how we said we try to draw an oval. So we try to draw it right around all the points. Oops, oh wait, I'm missing that point up here. So we're trying to get around the points, and that's not really much of an oval, right? It is kind of, because it's not really exactly a circle, but look at how wide this oval is, right? As opposed to what we were seeing before. Right? So here's what we call no correlation, because if we look at our line of best fit, maybe our line of best fit is that. But look at how really none of the points are really on the line of best fit. They're all scattered all over the place. Right? So nothing's really showing that as one increases, the other also increases. So we don't really see that with these no correlation. Now, what I want to show you guys is a website. All right. Here is the website. Okay, so let me blow this up a bit so you can kind of jot down the website. So here's the website. Okay, so you can go on this website. If you're struggling with some of your scatter plots, go to this website. And what's great about this website is it gives you a blank grid, and it allows you to plot the points on it, and it'll actually form the line of best fit for you. So if you're struggling with some of your examples when doing homework, go to this website. Okay, and I'll show you right now. So once we're at this website, so let me shrink this back again. Okay, now we're going to scroll down. Don't use the first one. Use the second one, because this is the one that it will actually give you your line of best fit. Let's see if I can expand this a bit. And hopefully it'll let me plot our points. So, here's one point, right? So I have one point. It's not going to plot my line of best fit because all it is, it's a coordinate, right? So think of the Cartesian plane when we said we plot a point. How do we know which direction this line is going to go? We need at least a second point. So here it is, my second point. My line of best fit will cross those 2 points. Right? Now I'm going to draw another line, or sorry, put another point on the line, another point close to the line, another point close to the line. Look at the relationship. It's strong because they're all on the line of best fit. They're positive because it's going uphill from left to right. But now watch what happens as I move away from the point. Right? So it's still positive, still strong because the points are pretty much in line with our line of best fit. But now watch what happens here. It's still strong positive, right? But now watch me start putting some more points in there. Look at that. It now just became weak. Right? Because the points are now deviating further away from our line of best fit. Right? And notice how now our line of best fit, now look at that. And look at what's happening right now. What's the relationship? No correlation. But the more points I put in, watch what happens now. I'm going to keep putting more points up here. Right? Because I might be taking lots of data. Now look at, we went from positive to negative because now the line of best fit is going downward. So the more points we plot, the better accurate we can get of a line of best fit. Right? So now, if we're going on the website, use this second one, right? So you're looking at any one of your examples and you try to estimate where all the points lie. Right? And there it is, no correlation with the little sample that I just gave you. Right? So you can do this with any of your homework questions. Now, if you keep scrolling down, right? If you keep scrolling down to the very bottom here, we have the scatter plot correlation. Notice here, strong positive. Positive because it's going upwards. Strong because, why? Why is it strong? Why? Yeah, all the dots go where? All the points lie on the line of best fit. Right? It's a line of best fit. So now watch what happens. Now I'm going to just change this. Now the points are going to slowly move away from the line of best fit. But that's the line of best fit. Still strong positive. Why? Because they're still pretty close to the line. But watch as they start to spread apart. Right? They're still considered strong positive. But what's going to happen next? What's going to happen after that? Weak positive. Because now the points are farther away. Right? So if we look at the oval that we would create. Right? Well, kind of got the sinking of the smartboard kind of changed when I stretched it out. So imagine how much wider it actually got. So if we still keep moving, right? Look at now the line of best fit. It's going from positive now, slowly, to flattening out. As it's getting close to flattening out, right? So notice, even though it's slightly positive, there's really no correlation whatsoever because look at where all the points are. You've got this point here up at the top. Look at how far away from the line. Look at how many points we have here at the bottom that are so far away from the line. So there's really no correlation whatsoever, which means there's no real relationship between the two, the independent and the dependent variable. So now as we keep changing our points, no correlation, no correlation. What are we slowly getting into with our line of best fit? A weak negative, right? Weak negative. Right? And ultimately, it's going to be when all the points start to match up, strong negative. Right? So as they're all on the point. So we can still have a strong negative and the points not being all on the line of best fit, right? As we have with this example. But the majority of the points are. Okay. Answer the following questions. For each of the graphs, right? You have 9 graphs there. 9 scatter plots on your page. And I'm going to show you the example in a second. Draw a line of best fit, if possible. Do the best you can. Some might not be that easy to draw. Then identify, is your scatter plot linear, non-linear? Is there a positive or a negative correlation? And is it strong, weak, or no correlation whatsoever? Okay, so take a moment and complete those practice problems. You should have completed the practice problems, and here we have the first example. Now, if we look at the line of best fit, right? Your line of best fit should go kind of like that, right? Kind of like that. As many points as possible. Remember, it's a straight line. It's not a connect the dots. Okay, it's not a connect the dots. It's a straight line, so you should be using a ruler. A ruler. Yes. You should have a line because really you want your line of best fit, because from here now, let's answer this. And answering this next question, linear or nonlinear, has nothing to do with the ruler. Is it linear or nonlinear? Linear. Okay. Now, the correlation. This is where the line of best fit comes to play. Right? The line of best fit is going positive or negative. Negative. It's going downhill. So it's negative correlation. Now, is it a strong, weak, or no correlation whatsoever? Strong correlation. Right? Because think about the oval, as we said, right? We can do the oval, and we'll notice that the oval is pretty narrow. Question? Brent, don't worry. We'll talk about that after. Now, let's actually talk about that now for this one at least. Okay, we'll talk about all the other ones later, but we'll talk about this one right now. Is there a relationship between the points? Yes, because as one increases, the other decreases. Right? Which is increasing? Dependent or independent variable? Independent variable, which is our x. So there's a relationship. Okay? But we'll talk about those a little more at the end. Next one. Our line of best fit, in fact, actually looks like that. And this one's one of the tougher ones to draw a line of best fit. Now, is this linear or nonlinear? Nonlinear. Positive or negative? Positive. Now, remember when we were talking about the positive, negative? Yes, but when it's flattened like that, it's pretty close to horizontal. We might not really show our positive or negative correlation. Right? Because in fact, is this a strong, weak, or no correlation? No correlation. So when our line of best fit is as close to being flattened as possible, there is no correlation. No correlation. So the positive, negative, right? Not really, right? Because remember, you may have drawn yours as a negative correlation, right? Your line of best fit maybe not have been as accurate, but you should know for a fact that there is really no correlation in this scatter plot, right? Because look, is our relationship is one increasing, is the other increasing as well, or decreasing? Are we getting that kind of information? No, because it's going all over the place. Right? The independent variable could be changing, yes, but the dependent variable could be increasing, decreasing. We don't really know. Next one. Linear, nonlinear. Non-linear, right? So they deviate, right? Now, these ones aren't really as easy to identify. Positive, negative correlation. Positive. Strong, weak, no correlation. Weak correlation. Notice how the points are still in line, right? They're still in line with the positive correlation, right? But they're getting further away from that line of best fit. Next one, a little bit simpler, right? These ones are, yay, I like these ones because these are easy, right? We draw our line of best fit, to the best of our ability. Linear, nonlinear? Linear. Positive, negative correlation? Positive. Strong, weak, no correlation? Strong correlation, very good. Next one, linear, nonlinear? Nonlinear. Positive, negative correlation? Negative correlation, right? Going down with strong, weak, no correlation? Weak correlation. Now, it's a weak correlation because, well, yes, as the independent variable is increasing, we are seeing a decrease in the dependent variable, but we're not seeing as drastic, right? It's going all over the place. So it's not really decreasing very steadily throughout as one's increasing. So that's why we struggle to say that it's considered a linear relationship. But there is a bit of a relation because we are kind of seeing, an increase, decrease between the independent and dependent variable. Next example, linear and nonlinear. Well, here's our line of best fit. Nonlinear, right? They're pretty much going all over the place. Positive, negative correlation. Positive, it's going uphill from left to right. Strong, weak, no correlation. Actually, no correlation here because they're going all over the place. We're getting very close to it being almost circular. Okay. And I'm basing this example from plotting this on that website as well. Right? So if you had an example and you're kind of iffy about it, go to that website, plot those points, estimate where they are, and see what kind of information it gave. But in fact, actually, I could give it, what could I give it? Instead of no correlation, I could say weak. Okay? So I could kind of say weak. Why can I kind of say weak? Right? Weak could be moderate. But another thing is, look at my line of best fit. Right? If it was no correlation, what were most of the line of best fit? Exactly, they should be almost flat. So you know what? Let's change this one to more this one. Let's get rid of that. Just because, right? Remember we said our line of best fit. If we had a line of best fit that was going kind of this way, or if it was going kind of like this way, where it's close to being flattened, right? There's really no correlation. But with our line of best fit. Now, next example here. Here's our line of best fit. Linear, nonlinear. Linear, positive, negative correlation. Negative. Strong, weak, no correlation. Strong correlation. Next one. Here's our line of best fit. Is it linear or nonlinear? Nonlinear. Positive, negative correlation. Kind of negative, but more importantly, it's no correlation, right? None whatsoever, right? Because look at our line of best fit. Our line of best fit is pretty close to being flattened. I think this is the last one. Here's our line of best fit. Linear or nonlinear? Linear. Positive, negative. Positive. And strong, weak, no correlation. Strong. So what we would say when we were to label this, right, if I was to ask you to describe this scatter plot, you would describe it as a strong, positive. We can ignore the linear part, correlation. Right? So strong, positive correlation. Sample problem. Create a scatter plot showing the ages and annual incomes of 11 members of a family. So this is the first example on the page of scatter plot. So go to the beginning of the scatter plot lesson. And this is the information. So now what we're going to do is we're going to plot it. But lucky for us, it's already been plotted in our book. Right? Yay! We don't have to plot it. Right? So this is the one example that we don't have to worry about doing. So notice what is on the independent variable. What is independent? Age, right? Remember we said time, age, stuff like that. That's usually the independent variable. Right? So, obviously, income depends on the age. Right? And that's really what we're trying to plot. At the first age, 25 years of age, the income is not $35, it's 35 times 1,000. So, but we didn't want to write down all those numbers. So that's how we might write it down. In thousands, right? Thousands of dollars. So 35,000. So if we plot the points as we've got them here, do we have, so tell me a little bit about the correlation. Is the correlation strong or weak? Moderate, right? Moderate. Maybe we could get it more strong because think about the oval. Yes, the oval kind of deviates because of this one, right? But if we look at the majority of the points, right, we can still consider it as a strong, right? And let's draw our own little line of best fit. We have one point that kind of deviates away from the line of best fit, and we can have that. But what does this kind of tell us? But in terms of most of the information, what does it say? As we get older, or as the family members get older, what happens? the more income you're receiving. So you're making more money as you're getting older, with the one exception of this 28-year-old here. Right? 28-year-old making how much? 75,000. Right? So maybe this person owns their own company. Maybe they're working 2-3 jobs. Right? So we don't really know what information as to why this person is making so much more, but for the most part, as age increases, so does the annual income. Okay, so we could say that as we get older, we're going to get paid more. As a teacher, my first year getting paid compared to what I'm making now, big difference. Because as I'm getting older, I'm making a little bit more and more money. Right? And that goes, the same will go with a lot of jobs, even with raises, right? Like, so if you're working at a company, or you're working at, some food place, whatever, right? You're making minimum wage when you start. Eventually, you'll start making, maybe getting a raise as, after a year, after another year, after a couple of months. So, but you're getting older, right? The independent variable is changing. Your age is changing. And your income is going to probably increase as well. So we can say that this is a strong what relationship? Correlation. Strong positive correlation.